I'm honored to have the opportunity to talk to you. So thank you for inviting me, and this is the first time I've been in Kenora. My mother was she was the oldest of 13 children, and their family lived for quite a long time, and some of them are still there in Port Arthur and Port William, which we now call Thunder Bay. But I never came up to this part of Northern Ontario. I've been to Atikokan, I've been to other communities, so I'm glad to finally enter Treaty 3 and be able to experience a little bit of the beauty of this country here. I don't know how to start the projector. Little technical glitch. Nature seems to arrange things quite well with living creatures, but these non-living creatures, we humans have to tend to them to make sure they're hooked up properly. There we are. Will that other thing go away?
I hope so.
A little higher. Okay. You do it. I can't see where. Hello? Does it come out? It's working? Okay.
Is it working? Yeah. Okay.
Can you hear me all right, everybody?
Yeah.
Okay, do I have to increase the volume or anything? Is it unlimited with it? Oh, well, there we go. Okay.
Action.
All right, well, in order for the screen is set up for me sitting down, so I'll get the image better if I sit here, if you don't mind. Well, as we heard during the ceremony, the water is so sacred, and really the whole earth is so sacred, and it must be protected. And water is one of the things that unites all living things. And what's happening here is that, as you know, down south they have built all these nuclear reactors to generate electricity, and these nuclear reactors, they have waste. Now, when we talk about waste, we normally think of something that is rejected, that it was already there, but it's in the part we don't want. In the case of nuclear waste, it's not the part we don't want, it's the part that was never there in the first place, but it was created inside the nuclear reactors. In other words, this waste is not an unwanted part of what we started with. It's a brand new collection of materials that are very poisonous and that were created inside the reactor itself. In fact, these materials were never seen on Earth before 1939, which happens to be the year before I was born. So I really am the same age as these wastes. Before I was born, these wastes did not exist. So we're talking about a problem of recent manufacture, recent creation. And bear that in mind, because we really don't know what to do with these wastes right now. And the idea that we're rushing to find a so-called solution really has more to do with the nuclear industry's public relations. They want to convince people that they know a solution. We do not believe, many of us, that they do know a solution. It's a mistake. That they think they have a solution, but they don't. They think that they can put the waste into Mother Earth and that it will never come back. But you know, Mother Earth is a great recycler. Mother Earth recycles everything. In fact, in nature, there's no such thing as a waste product, because whatever is a waste product to one species becomes nourishment to another species. And the great cycle of life continues in this way. So what we have here is something which is antithetic to life, and they want to put it away and banish it from the natural world. But in fact, we humans do not have that power. So I started my talk by posing a few questions that I think are important to ask. The title of my talk is Radioactive Waste, The Questions Multiply. And not only the questions multiply, but the waste also multiplies. Because even as we speak, more waste is being created. And if the nuclear industry is able to get the agreement to put the waste up here in Northern Ontario, they have no intention of stopping to produce this waste. They just want to keep on producing more. So it is not, as they would like us to believe, a way of getting rid of this waste. It's a way of perpetuating it. And this must be borne in mind. Now, so I'm going to go through these slides. The first promise that I think we should be very concerned about is that Canada will not import radioactive waste from other countries. This is something that the Nuclear Waste Management Organization, NWMO, has been telling people in the North. No, we won't import radioactive waste from other countries. But then, just a couple of years ago, ex-Prime Minister Jean Chrétien, we discovered, was secretly negotiating to import waste from other countries to bury in Labrador. Here's the Prime Minister of the country, the man who was the Prime Minister of the country. He knows very well what the promises were. He knows very well that people were told that Canada will not import radioactive waste. And there he was, as a lawyer, working secretly to do exactly the opposite of what has been promised. So one has to bear in mind, and I'm sure that of all people, Indigenous people know best of all, that these promises that are uttered are not always meant to be kept. They're not always kept, and sometimes they're not even meant to be kept. So former Prime Minister Jean Chrétien was part of this secret effort. This story came out on April the 1st, 2021. April 1st, in my culture, we call that April Fool's Day. We play a trick on people. Well, that's a pretty dirty trick. Now, another promise that we have been told before, because NWMO has been in this northern part of Ontario for about 13 years, and they've been meeting with communities all the time, sometimes on a monthly basis, and they have always implied that the DGR, the Deep Geological Repository they want to build, would only be for the fuel from the Canadian reactors that are now operating, and the ones that those reactors will continue to produce until the end of their lifetime. This would evolve to about 6 or 7 million fuel bundles. Each fuel bundle is about the size of a fireplace log, but it would kill any human being to come close to it for any length of time. As a matter of fact, these fuel bundles, when they come out of the reactor, just as they come out, they are so radioactive, they give off invisible rays, that any human being standing within 1 meter of one of these bundles would get a lethal dose of radiation in about 20 seconds. That means that 20 seconds of exposure at a distance of 1 meter without even touching it would be deadly. So that's why it's all handled by robotic equipment. It's not handled by human hands. In fact, these waste bundles will never be handled by human hands again. It's only by robots. And when they come up here into the north, they have to unpackage them That has to be done with robots. And then they have to be repackaged. That has to be done with robots. Now, they don't use actual robots. They use what are called robotic arms, that a worker standing behind a window that is 3 feet thick uses these robotic arms to manipulate these bundles. Why? Because to be any closer would be deadly to the worker. Now, but these promises, this is another promise that, in fact, they're not going to keep. Because they're now talking about building a whole bunch of new reactors called small modular reactors. They use the initials SMR. And they say, oh yes, we can even put them in northern communities. Maybe, you know, you could stop burning diesel fuel and you could use these small modular reactors. Up in the Ring of Fire, where they want to exploit the minerals, they want to put nuclear reactors up there for the mining companies to be able to use the energy of the nuclear reactors to more rapidly exploit the minerals from the earth and create the kind of damage they do in doing so. So there's another promise that's not being kept. Small modular reactors are already planned. There's one planned for Chalk River. It's called a micro-modular reactor. It's cooled by helium gas, not by water. There's another one called the Moltex stable salt reactor in New Brunswick. It's cooled by salt that is heated to about 800 degrees Celsius, much higher than the boiling point of water. And that's called molten salt, and that's the coolant for this reactor. Another one in New Brunswick is the ARC-100 liquid sodium cooled reactor. Now, sodium is a metal, and when it's not when it's all by itself as a metal, it reacts violently on contact with water. If you go on the internet and look at metal, sodium in water, you will see that they drop a little bit of sodium into water and it runs around like a crazy man because it's reacting violently with the water and gives off heat. So this makes it particularly dangerous to put underground because the water will react with it and cause chemical reactions to occur. They're also building one in Darlington, which is a boiling water reactor. It uses water, ordinary water, as a coolant, but they allow it to boil in the core of the reactors, which does not happen in a can-do reactor. In a can-do reactor, it's called a pressurized water reactor. The water is not allowed to boil inside the core of the reactor. So there's another promise that's made, and that is that used fuel will not be reprocessed for plutonium. What does that mean? What is this word plutonium? Plutonium is one of those elements that never existed in nature before 84 years ago. And plutonium is created inside a nuclear reactor. It's actually a derivative of uranium. It turns out that uranium, there's two kinds of uranium found in nature. They're blended together. One part is used as the fuel of the reactor that generates all the heat. The other part does not generate that heat, but some of it turns into plutonium. So plutonium is manufactured inside every nuclear reactor. Now, the reason plutonium is talked about is because the first reactors were built not to produce electricity, but only to produce plutonium for atomic bombs. It turns out that it's the principal nuclear explosive in the world's nuclear weapons. So that when you talk about the thousands of nuclear weapons that are in the world, the tens of thousands in fact, most of them use plutonium as a nuclear explosive. And some of the people in the nuclear industry, they would like to extract that plutonium out of the used fuel before burying it. And to extract it out of the used fuel because, not because they want to make bombs, but because they want to use it to build more reactors and use it as fuel for those additional reactors, which in turn will create more nuclear waste. So it's not a way of putting an end to nuclear waste at all. If somebody tells you that we're extracting the plutonium to get rid of the nuclear waste, they're lying. It's not to get rid of it, it's to allow them to continue to make more and more and more. In fact, they think it'll extend the lifetime of the nuclear age by hundreds of years even, if they could do this. So will that promise be kept? Well, no, they're already violating it. In fact, in New Brunswick, the Moltex reactor that I mentioned earlier, the one that uses salt as equivalent, they want to actually extract plutonium from the existing used fuel, the stuff that is planned to come up here. They want to extract that plutonium to use it as fuel for the molten salt reactor. So the point here is that these promises are not being kept, and that I believe that the First Nations people are very aware of the fact that promises that are made by governments and by industry are often not met. I mentioned about reactors and bombs. You see this little graphic, it was drawn by a friend of mine, Robert Beltredici. He has the bomb on one side and fire in the middle and the reactor in front of it. And I told him, he said, well, why can't they just take the used fuel and use it to make a bomb? And I said, well, there's a firewall. And so he drew a wall of fire. I said, there's a firewall between the reactor and the bomb, and that firewall is radioactivity. As I mentioned, these bundles are so radioactive that they will kill any human being who comes close to them. So that radiation prevents people from using the fuel directly to make bombs. It will kill them. So that's why separating the plutonium is very dangerous, because when you separate the plutonium, you use something called a reprocessing plant. And that reprocessing plant is a factory robotically run with robots that disassembles the fuel and extracts the plutonium. And once that plutonium has been extracted from the highly radioactive waste, then it can be used for fuel, but it can equally well be used for bombs. So just by taking it out of the spent fuel, you're making it more possible to make nuclear weapons. And since we want to sell these reactors around the world, you could expect that many more countries will be getting nuclear weapons that did not have the ability to do so before. So that's why our organizations, Renee's organization, We the Nuclear Free North, and my organization, the Canadian Coalition for Nuclear Responsibility, we have been urging lawmakers and people in Ottawa, we're going to be there next week in fact, to ban plutonium reprocessing, to ban the extraction of plutonium from the used nuclear fuel. If they get the ability to bring the fuel up to a place like Ignace, the chances are good that they will want to try and extract the plutonium there. And the danger is that when you open up the fuel to get the plutonium out, you let out all the other things as well. And so therefore, you make this stuff much more available to the environment. And for that reason, plutonium reprocessing creates a great deal of contamination of the local environment, and is particularly dangerous. In fact, the sites in the world, the sites that are the most radioactively contaminated that we know of, are all places where they did plutonium separation. Hanford, Washington is in Washington State. That's where they separated plutonium from the bombs originally, and it's very contaminated. It's going to cost over $100 billion to clean up that, just to clean up that site, without even getting a solution to what to do afterwards. Same thing in northern England, there's a place called Sellafield, another $100 billion cleanup. That's where they were extracting plutonium. In Russia, they have a place called Mayak, where they were doing this, and it's terribly contaminated. So these are among the most contaminated, radioactively contaminated places on Earth. It's where they did this plutonium reprocessing. Now, they claim they have better technologies. They claim that they've improved it. They're using technologies that don't cause such extensive contamination. But again, do not believe them, not 100%. Yes, it's true that technology marches on. No, it is not true that all the problems are solved. Not at all. So this brings us to the Indigenous rights and how are they affirmed and exercised. Well, far be it from me, but I believe that living experience has shown that Indigenous people have benefited greatly from legally binding documents that can be argued in a court of law. So when you have something that is written in paper that specifies, and it's a legally binding document, you can go to the courts, and the courts will not allow the government to violate these laws. They say you are subject to the law too, and therefore the indigenous people have rights, and you cannot just ignore those rights. If the courts had not been there, I don't think indigenous peoples in this country would be able to enjoy what rights they do have, which are very limited, but at least they do have those rights. And the NWMO and the government are scared of those indigenous rights because, as Prime Minister Trudeau says, it's a nation-to-nation relationship. And these treaties are binding between nations. And therefore, unlike myself, who is not indigenous, I do not have the same rights that you have, because you constitute another nation. And as a nation, you have power, actually, to exercise. And I do hope that, first of all, you have the power to refuse, but also you have the power to stipulate what should go in that agreement and what should be specified. For example, you could insist that no reprocessing is to be allowed. You could insist that no opening up of the fuel is to be allowed. But you could even insist that the waste doesn't even come here. So the important thing is to realize that you have much more strength than is immediately obvious on the surface. It doesn't look like you have a great deal of strength, but in fact you do. In Quebec, we had the Cree nations of Quebec brought about a halt to uranium mining in the whole province of Quebec, starting with their own territory. They came to a consensus that there would be no uranium mining. Uranium is the raw material from which all nuclear waste originates. And they said, we will not allow it on our territory. In fact, that brought about a one-year environmental assessment in Quebec, which led to a unanimous recommendation by the panel that this moratorium should be made for all of Quebec. This halt to uranium mining should be made for all of Quebec, and it should be made permanent. And here they are, all the people, I'm one of those people, participating in the World Uranium Congress, which was partly organized and paid for by the Cree Nation of Northern Quebec. And they were also played a great participation in it. And people were delighted that this very strong document was produced. Now, unfortunately, it has not been made into a law. Nevertheless, uranium exploration and mining in Quebec is gone. There's none taking place because nobody dares to violate this. That's not a permanent thing. We have to turn it into a law, but we're working on that to try and get a law made. As happened in Nova Scotia. In Nova Scotia, they actually made it law that you cannot even explore for uranium in Nova Scotia. So, preventing permanent radioactive contamination, I think one of the most important things is do not allow the on-site handling of damaged used fuel bundles. And we don't know how many of these used fuel bundles are damaged because nobody has opened up these dry storage containers. They have been sitting there for years and years. They've never opened up any of them. And they've been sitting there for 30 years. They will not move the waste until it is 30 years old. Why? It's too hot, it's too radioactive, it's too dangerous. So they have to wait for 30 years before they move this stuff up north. And it's up north that they want to open up and handle these fuel bundles one at a time for the first time ever. These fuel bundles that are so radioactive have never been handled before. So it will be done up north, and they don't know how many of them are damaged. Now, why is the damage important? Well, the fuel bundle is really the container of the waste. It's not actually the waste. The Nuclear Fuel Waste Management Organization, NWMO, they like to hold up a bundle and say, look, this is not going to put deep underground, it's not going to come back. Well, they're right, but that's only the container. Once the container is broken, the contents spill. And those things can come back. And the things that are inside are gases, and some of them are vapors, which can float in the air, and some of them are dusts, which can travel with water currents and so on. So these things can, in fact, escape, and they are expected to escape in at least very small quantities. But if they're badly mistaken, they could escape in much, much larger quantities. So, Renee, do you have an idea how long I've talked already? I don't want to go too long and waste your patience, because I know we want to have a discussion.
21 minutes.
Well, okay, well, I've already spoken for 24 minutes, so if your permission, I'm going to speed up now, talk faster, and give you a little rundown on what this whole industry is about. It all starts with uranium. This is a model of the uranium atom down in Oak Ridge, Tennessee. And that's where they built the first uranium atomic bomb. And the first uranium atomic bomb, now uranium is the key element behind all nuclear fission technology. Nuclear fission is obtained when you break an atom apart. And there's only one element in nature for which you can make an atomic bomb, or for which you can make fuel for a nuclear reactor. There's only one naturally occurring element, and that's uranium. And so uranium, this is the one bomb made from highly enriched uranium was dropped on the city of Nagasaki on August 6, 1945. And look at the destruction. And this is simply from these tiny, tiny little atoms being split by tiny little projectiles called neutrons. And look at the devastation that results from that. Now that same process of splitting atoms is used in a nuclear reactor, but it's used in a controlled fashion. So instead of a violent explosion, you get a steady output of energy. Now that in itself sounds good. You say, well, if they can control it, wow, thank goodness for that. And if they can get useful energy out of it, that's a good thing too, isn't it? And it is, except for one thing, that when they split the atom, they use, as I say, a thing called a neutron, very, very tiny. And the atom splits, but it doesn't disappear. Energy is released, yes, a lot of energy, but you have these broken pieces of the uranium atoms. And there's hundreds of these broken pieces, and they all are brand new elements. Most of them never existed in nature before 1939. And you know, in nature we have things like iodine, which is not radioactive. Well, the nuclear reactor produces radioactive iodine. And in nature we have a thing called cesium, which is not radioactive. The nuclear reactor produces radioactive cesium. So what the nuclear reactor does is it produces radioactive varieties, poisonous varieties, of materials that are already in nature but are not radioactive. And that's the difference. Now these new elements, they behave just like the non-radioactive elements, except for the fact that the atoms are actually exploding. Now when the energy is released and the fission products are produced, you get more neutrons coming off as well. And the reason for that is that those neutrons are able to go on and split more atoms. And so you get what's called a chain reaction. And if that's done in an uncontrolled fashion, boom, there goes a city. If it's done in a controlled fashion, you have a nuclear reactor. So the main thing to remember is that nuclear fission is only 84 years of human experience. Imagine me, I'm 83, so I'm going to be 83 in July. Imagine if I died and my body didn't disappear, it just lasted for 10 million years. And it was also very, very toxic. My body was the worst poison you could imagine for 10 million years. And it was even unapproachable. Anybody who came close to my body could get a lethal dose of radiation. Well, that's what the nuclear industry is doing. It's producing these radioactive wastes, which are going to... So, in a way, the way I look at it is this, that the reactor starts operating. It produces maybe 10 or 20 or 30 or 40 years of electricity if you're lucky. But it also produces radioactive waste, which goes for 10 million years. So it gives you a benefit for 3 generations, and it gives you a curse for 300,000 generations. What kind of a bargain is that? And this is the main problem here. Now, the plutonium comes about because when a neutron strikes another type of uranium atom, that uranium atom doesn't split, but rather it gets a little bit heavier, and it turns into plutonium-239. It was uranium-238, it becomes plutonium-239. So that's how the plutonium is created. Not a fission product, because it's not the result of breaking, it's a result of what we call breeding. It's breeding a new element. And there's a bunch of other new elements that are bred in the same fashion. So now this glass ball is exactly the same size as the ball of plutonium that was used in the bomb that destroyed another city 3 days after Hiroshima. A plutonium bomb was used to destroy the city of Nagasaki. And actually slightly more powerful than the Hiroshima bomb. Now I use this, this is from the Hindu scriptures. It's about the god Krishna. The god Krishna in the Hindu scriptures has many incarnations. The incarnations, they're called avatars. And they're like personalities of the god. So the god manifests itself in different ways. And this is a statue representing 24 different avatars of the Hindu god Vishnu. Yeah, sorry, Krishna is only one of the avatars. I made a mistake. The main god is Vishnu, and one of his avatars is Krishna. So I use this picture because it reminds me that uranium, when you're thinking about uranium, remember that it's not a single thing. It's actually hundreds of different things, because it generates all these fission products. There's hundreds of them. It generates plutonium and the transuranic elements, the ones that are heavier than uranium. There's dozens of those. And so we have really an element that is a shapeshifter. And it manifests itself in many different ways, most of them poisonous. Okay, now, what is radioactivity? This is a key thing to understand. What is a radioactive atom, and why is it different from a non-radioactive atom? Well, a non-radioactive atom always stays the same forever. It enters into different combinations. For example, hydrogen and oxygen combine to make water. And they can break apart the water molecules. You get the hydrogen and oxygen atoms back again. And they're still around, and they can be recombined again to make water, or to make the cells in our body, for example. But radioactive atoms are like little time bombs. They explode. And that's not what a normal atom does. And when a radioactive atom explodes, it gives off particles, which are called atomic radiation. And these particles are what break the bonds in your body. They break the bonds of cells. So the cells get damaged. And you know, living cells have the ability to reproduce. And so sometimes when these cells are damaged, not all the time, not even very often, but sometimes when these cells are damaged, they start reproducing abnormally, and they become a cancer. And so that's why radiation causes cancer. And nobody denies this. Everybody knows that radiation causes cancer. And it's one of the reasons they want to get rid of this waste, because they don't want. There's enough cancer-causing material in these wastes to cause billions and billions of human cancer. And they don't want that to happen, so they want to put it somewhere safer. And they think that putting it underground will do the trick. But of course, on the way to putting it underground, they're going to spill a lot of it too. And that's a danger for the people, because once it's spilled, then it's out there, and it's causing a lot of damage anyway. This is what it looks like if you put it in a cloud chamber. That's a special device that allows you to see the tracks of those invisible particles. And this is a piece of uranium ore. It's a rock. And look at those particles coming off. And the amazing thing is that those particles are coming off 24 hours a day, 7 days a week, year after year, month after month, decade after decade, thousands of years after thousands of years. This has been going on for millions of years. This same rock has been giving off those particles for millions of years. And it's almost amazing. The people who discovered it could not believe that so much energy was coming off a simple rock. And actually has something else you should bear in mind, that when the waste is put underground, it's not just a rock. It's not something that is inert. It's something that is active. It's radioactive. That's why they use the word active. And it also generates heat. It's thermally active. And they have to worry about the heat that's being generated. And it's also chemically active. It turns out that these particles actually cause a lot of chemical reactions to take place. In one underground repository for nuclear waste in the United States, the radiation alone caused chemical reactions to occur in a steel drum. That drum exploded and turned into a flamethrower. And the radioactive dust made of plutonium dust, went 750 meters straight up vertically to the surface, contaminated 22 workers, and then drifted downstream. So that would not happen normally with something you bury underground. But this stuff is active. It's chemically active, so it's causing things to react and enter into different combinations. It's also generating heat, which can push things. There's what the fuel bundle looks like. Notice the hands holding it. The only reason the hands are holding it here is because either it's empty or it only has raw uranium in it. Uranium itself will not give you a lethal dose of radiation by being so close. But once that same bundle comes out of the reactor, it would kill any human being in a very short period of time. And here is a list of some of those products that I was telling you about. These are the waste materials. They're all radioactive and they're all in every single fuel bundle. And this list is something I got from Atomic Energy of Canada Limited. Every one of these materials has a different properties. They're all chemically different. They all have different pathways through the environment and through the human body. And this list of 211 radionuclides is in 10-year-old spent fuel, 10-year-old used can-do fuel. It would also be in 30-year-old used can-do fuel. And as time goes on, some of them die down and disappear. Others last for millions of years. So although some of the waste goes away, some of the waste never goes away. And you have to be aware of that too. And some of the waste that never goes away is among the most dangerous of all. So when they put this waste into a package down at Pickering at the generating station outside of Toronto, you see this package here? Well, that package weighs 70 tons. But the fuel inside, you see those sort of cylindrical fuel bundles poking out? They only weigh 10 tons. So you have the fuel that weighs 10 tons inside a package that weighs 60 tons. Imagine having a refrigerator and a package for the refrigerator that's 6 times heavier than the refrigerator. Why do they do that? They do that because it's so radioactive they need to have a lot of protection. So otherwise the workers would get overexposed. And so they put it in this very heavy. Now at the very top they have what's called a safeguard seal. You see that thing in red? It's called a safeguard seal. Why is that there? The reason that's there is to give international inspectors the ability to see that it has not been tampered with, that nobody has broken into it. Why? Because it contains enough plutonium inside this one container to build 6 or 7 atomic bombs. There's enough plutonium in there to build 6 or 7 atomic bombs. And the safeguard seal is to guarantee that nobody has been taking that plutonium and using it for bombs. That's basically what it's there for. This is how they're going to truck it. They're going to put those bundles into a much smaller container, only after 30 years of cooling off. And then they will truck it over these rough roads leading up to northern Ontario. You can imagine how much shaking is going to go on those roads. And what happens if you have accidents? Even collisions that don't overturn the truck could shake up the rods and cause damage. Any kind of damage to the rods will allow the radioactive materials to escape from the rods and get into the environment. When they get here, they have to use what are called hot cells to handle them. These hot cells have those robotic arms I was telling you about. Each hot cell has 2 robotic arms, and they have windows that are 3 feet thick to protect the workers. And they have, in the glass, they have lead. It's called leaded glass. And that's to stop the radiation. Otherwise, the workers would be killed. So they have this very thick leaded glass to protect the workers who have to handle the fuel bundles robotically. And they're going to put the fuel bundles, take them out of the transport containers, and put them into these burial containers. They're called used fuel canisters. That's for putting it underground. They're made of stainless steel coated with copper. And the copper coating is only 3 millimeters thick. In Europe, they have a similar kind of plan, except their copper is 50 millimeters thick. So in Europe, in Sweden and in Finland, they're using copper that's 50 millimeters thick. Here they think they can get away with 3 millimeters thick. And really, the main reason for that, we think, is simply because it costs less money. So it's difficult to, and some scientists have really questioned why they are doing this, why they're even using 2 different metals, because using 2 different metals actually accelerates corrosion. It doesn't slow it down, it actually accelerates it. If there's any penetration, even a small penetration of the copper, it will actually cause more rapid corrosion than would have happened if there was no copper there to begin with. So this is a problem too. That's what they look like in real life, but those are empty ones. When they're full of spent fuel, it turns out that these copper canisters are giving off, you see those glows, see that glow around the fuel bundle there? That's indicating the radiation. And the green glow is what would happen if you were close to it. The blue glow is what would happen if you were a little further away from it. In that green area, a worker would receive his one-time annual maximum exposure to radiation in 1.3 minutes. 1/3 minute, he would receive his year-long maximum. It would mean that he'd have to be laid off. He couldn't go to work anymore because he wouldn't be able to get any more radiation exposure. That's his yearly maximum. He could get it in less than 2 minutes. But there's a 5-year average for atomic workers, which is much more strict. And he would get that in 40 seconds. And for a member of the public like yourself, if you or a child happen to be somehow in proximity, they would get their overdose in 1.5 seconds. So in 1.5 seconds, you would be overdosed. You'd have your whole year's worth of maximum radiation exposure. So these things are going to be very difficult to handle. And taking them down underground, a vertical shaft and everything, you can imagine what kind of accidents might happen, especially when people can't just go there and lift them out and tuck them under their arm and carry them off. There's no way they can do that. So I'm going to now, this is what a damaged fuel rod looks like. This fuel rod is badly damaged. You see that long crack it has. It doesn't need to be that badly damaged, but that's a real fuel rod with a real crack in it. These things happen. You don't need to have such a bad crack. You could just have a little crack. You could even have a little pinhole. Anything that will allow radioactive material to escape, it will escape. And it's because of the heat. The heat is very intense, and that heat pushes it out. So I'm going to, inside a reactor, I just want to mention that this happens all the time. If anybody tells you that no, it's not going to leak, you tell them that you do not believe them, because even inside our reactors, it leaks all the time. This is what a reactor looks like. It's just a drawing, of course. That square yellow section is where the fuel is. That's where all these radioactive materials are created. But look at that purple thing up there. That's a boiler. And those boilers, they become radioactively contaminated, and they have to be disposed of as radioactive waste. Question, how do they get radioactive? The reason is because the fuel bundles are leaking. And the fuel bundles leak, and the water carries it to the boiler. And there it deposits on the, you know what a scale's developing on a boiler, right? Well, the scales develop with the radioactive scales. So if anybody tells you that these things don't leak, you know that they're lying, because they leak all the time. This is one of those steam generators. They want to ship these through the Great Lakes. They had 16 of these. Each one weighs 100 tons. They want to ship them on a barge through the Great Lakes and along the St. Lawrence River and over to Sweden for recycling into scrap metal, which would mean that people buying metal objects wouldn't even know that they're buying radioactive metal. They're buying metal that's actually radioactive because they want to melt it down and blend it in with other metal. 400 municipalities in Quebec passed resolutions opposing this, and we even had resolutions coming from cities like Toronto, Quebec City, Montreal, and even Chicago and Detroit, cities in the United States, all protested against this, and they never shipped them. They never shipped them. So you can stop their plans, but in order to stop their plans, you have to let them know that you're not going to allow it. It's not going to be allowed. And this has to be a loud and clear message. And we've stopped things before, and we will stop them in the future. And that's how it has to be done. Now, even inside these steam generators, look, this is a list of things that are inside the steam generators. I know you can't read that list, nor do I expect you to. But I want to point out to you, however, I'm trying to go back and I'm using the wrong button, sorry. But in that list there are, get a load of this. This is inside the boilers, There's 8 materials that have a half-life of over 1 million years. A 1 million-year half-life means that it takes 1 million years for just half of it to go away. Just half of it. And then the other half takes another, not just 1 million years, in another 1 million years, only half of what remains goes away. And then another 1 million years, only half of that goes away. And then another 1 million years. So this goes on for, when I say 10 million years, it's way longer than 10 million years. 8 materials with a half-life of 1 million years, 13 have a half-life of over 100,000 years, 19 have a half-life of over 1,000 years, and 21 have a half-life of over 100 years. So you can see that these materials are going to remain dangerous for a very, very long time. And that's only in the steam generators. Far, far, far worse. Thousands of times, millions of times worse in the spent fuel itself. This little diagram here, I got this off the internet and colored the egg myself. I colored the egg gold to symbolize the old legend about King Midas. Have you heard the story about King Midas? King Midas had a magic touch. He could touch something and turn it into gold. And he loved gold, and so he got this magic gift of touching everything into gold. But of course, you know, he didn't live very long. What could he eat? As soon as you touch anything that turns to gold, you can't eat anything. And so you die. And, my friend Robert Del Tredici told me that, well, in the case of King Midas, everything turns to gold. But in case of nuclear power, everything turns to radioactivity. Everything turns to nuclear waste. What it means by that is, just as that steam generator became radioactive just by being close to the core of the reactor, right? The fuel is not in the steam generator. Nevertheless, it becomes radioactive. It's the reverse Midas touch. And when they put these fuel bundles into containers and ship them up here, guess what? The containers become radioactive waste. They also have to be buried. When they build a plant to sort of repackage the waste, the whole plant becomes radioactive. It becomes radioactive waste. So in fact, radioactive waste touches, whatever it touches, turns into radioactive waste as well. And for that reason, their planning is often thrown off. In New Brunswick, they wanted to refurbish a nuclear reactor, and they anticipated how much radioactive waste there would be. By the time they were finished, they had 5 times the volume of the nuclear waste they had predicted. Why? Because the containers became radioactive. Non-radioactive materials were mixed with radioactive materials, and it all became radioactive. And so in this way, just by carelessness, just by not keeping them separate, they multiplied the volume of waste by a factor of 5. That's also going to be happening up here if they bring it up here. Everything it touches is going to become waste. And those transport containers will be waste as well. This is another diagram from a friend of mine in Saskatchewan, just showing all the pathways of these radioactive materials. We're talking here about real substances, not invisible rays. These are real materials that really get out into the environment and really enter the food chain and therefore enter your body when you eat the food, drink the water. And they won't kill you right away because they're diluted down to a very low level. You have to have a rather large dose of radiation to be killed by it in a short time. Just like people smoke cigarettes. You don't see them smoking a cigarette and dropping down dead right afterwards. But what happens is it's a slow process, and they die years and years later, perhaps, from more lung cancer and so on. That's mostly because of radioactivity in the tobacco, by the way. But at any rate, they use radioactive fertilizer, and that gets into the tobacco, and that actually kills an awful lot of people. It wouldn't happen in nature in the same way. This just shows you how these are just hundreds of different materials that are chemicals which have exploding atoms. And when they get inside the body, they go to different parts of the body depending on the chemistry. So for example, radioactive iodine goes to the thyroid gland. There were 5,000 children in Belarus who had to have their thyroid gland surgically removed because of iodine, radioactive iodine from Chernobyl. Is there radioactive iodine in nature? No. Only what we have made in nuclear reactors and nuclear weapons. Iodine in nature is not radioactive. Similarly, here's strontium-90. Is there strontium in nature? Yes, it's not radioactive. But strontium-90 is radioactive, and it goes to the bone, and it causes bone cancer and leukemia and other diseases of that sort. Cesium-137 goes to the muscle tissue, and it makes meat unsuitable for human consumption. Right now, today, if you go on the internet and you Google radioactive boars, B-O-A-R-S, pigs, radioactive boars, you'll find that there are countries today, in Germany, in Belgium, in the Czech Republic, and in Japan, where the boars that the hunters kill in nature are too radioactive to eat, too radioactive to use the meat. Why? Because the boars like to eat mushrooms. They like to eat fungi, truffles in particular. And those mushrooms are very good at collecting radioactivity. And so the boars become very radioactive. And this is a fact that today, when hunters in Germany or those other countries kill a boar, the government pays them money not to eat the meat or sell the meat. So they pay them money in lieu of having the benefit of being able to use that food, use that meat as food. So listen, I think I've spoken long enough. This is the last picture. These are young women in Asia, in the old Soviet, remember I mentioned the Mayak plant in Russia? The Mayak was a plutonium separation plant. These women were photographed when my artist friend, Robert Del Tredici, was there to photograph them. And they are just learning now for the first time that the thing that has been killing so many of their neighbors and relatives and fathers and grandfathers and uncles over these many years is because of radioactive pollution of the river that flows past their village called the Techa River. And it's one of the most radioactive rivers on Earth. And the reason why is because when they were making the bomb, they wanted to speed up production, so they dumped radioactive waste directly into the Techa River. And the doctors were not allowed to use the word radioactivity in telling these people about the illnesses. And so they said, your people are getting sick and dying from vegetative syndrome, because they had to make up a phony word, because they were not allowed to say it was due to radioactivity. So we have many bad stories like this, and I just wanted to say one more thing, even though I'm finished. I do want to say it afterward, and this is in response to somebody who approached me before the meeting saying that they didn't want to raise this after my talk, but so they wanted to raise it before the talk. And they said, what do we do instead with this waste? And the answer, we feel, is that we should be humble enough to realize that we are not the lords of creation. We do not have a solution to this problem. This is a problem that defies our powers. We don't have the power to keep these promises that are being made. And we are lying to people when we tell them we're going to keep these promises. So what we should do is we should keep this waste where it is produced under very close surveillance. And we should be prepared to spend the money to improve the packaging of them. We do know how to package them in such a way that they do not get into the lake, they do not get into the river, they do not get into the air. We know how to do that, but not forever. No package lasts forever. So we have to be prepared to repackage it. And if a package starts leaking, we have to have people there with the right machinery to see that it's leaking and to take corrective measures, to gather the radioactive leakage together and repackage it all so that it's even better than it was before. Now this is not a solution, but it's a responsible way of managing the problem. And in fact, we should, of course, stop producing more. We should stop producing more, and we should manage the waste we have in a responsible fashion, not dig it underground, put it underground, and then abandon it. By abandoning it, we're simply being irresponsible. It's just like you abandon your family. You say, well, no problem anymore, the kids are gone. Well, they're not gone. They're just somebody else is either looking after them or not looking after them. And similarly with these wastes, abandoning them is no solution. It's an irresponsible act, which is really a betrayal of their responsibility to humanity and to the planet. Thank you very much. Now, we have a moderator. I think we could take questions and answers for a period of time if you wish. No, the chairman. Oh, no. You sit, no, I'll stand. I've been sitting too long.
Go ahead.
Okay, and what happened in Japan there with that?
That's a very good question. I will tell you, it's a very interesting situation, and it has a lot to do with radioactive waste.
Yeah.
It turns out that inside the reactor, you have these fuel bundles, and the uranium atoms are being split all the time and releasing a lot of energy, which boils water. And when the water turns to steam, the steam can then be used to turn a wheel and generate electricity. That's how they generate electricity. It's just another way of boiling water. That's all it is. Just another way of boiling water. But in the process of boiling the water, the advantage is you're not causing any carbon dioxide emissions because you're not burning anything, but you're creating this radioactive waste, which is going to be around for 10 million years. So you're hardly solving the problem. Now here's the thing, is that we know how to stop the neutrons from flying around. And in that way, we could shut down the reactor very quickly. Any reactor can be shut down in less than 2 seconds. And that's exactly what happened in Fukushima. When the earthquake struck, the shaking occurred, those reactors were safely shut down right away. So those reactors were safely shut down. But you know what? You can't shut off radioactivity. The exploding atoms continued even though the reactor was shut down. Nobody knows how to stop radioactivity. That's why we have a radioactive waste problem. Now, if you don't cool the waste, it's the waste that caused the meltdown. What happened is that when the tsunami came from after the earthquake, the tsunami drowned all the backup generators so that there was no way to generate any electricity inside the plant or outside the plant. And that meant all the pumps stopped. And that meant there was no way to cool the radioactive waste inside the reactor. And the temperature went up and up and up and up because you could not remove the heat being generated by the waste. Now the amazing thing about this is that within a matter of a couple of hours, it takes maybe 2-3 hours for the heat to get up to the melting point of uranium oxide fuel, which is around 3,800 degrees Celsius. And that's already twice the melting point of steel. So when it starts melting, everything it touches melts because it's way, way hotter. It's like candle wax in that sense. And all of that radioactive waste just melted right down into the ground. 3 of those reactors melted down like that. That's what happened at Fukushima. That's also, in a faster fashion, that's similar to something that happened at Chernobyl in the Ukraine many years ago as well. And in 1986, there was a complete meltdown in Ukraine. You may not know this, but in Canada, our first reactor, which was called the NRX reactor, that was built in 1947, it started up in 1947. It was designed in 1944, but it started up in 1947. It had a meltdown in 1952. People don't talk about it, most people don't even know about it, but the first serious nuclear accident in the world was at Chalk River, Ontario, with the NRX reactor. So that's what happens. And when you see all that radioactive contamination coming out after a nuclear accident, that's exactly the stuff we're talking about. It's the radioactive waste which have been released from the fuel because once it's melting, it's like you have a glass of poison. You break the glass or melt the glass, the poison's out. So it's a container that is destroyed and that releases the radioactivity into the environment. Yes?
How was the calculation made that the nuclear waste lasts 10 million years?
That's a good question. Actually, you know, the strange thing is the idea of the half-life was actually discovered long before nuclear power was. It was a man named Ernest Rutherford working in McGill in Montreal who actually discovered this principle of the half-life. And what he found is that all these radioactive materials, they didn't have nuclear reactors in those days, but he was studying uranium and the byproduct of uranium, which is natural. And he found that every little component of uranium, because there's a dozen or 2 of them, that they have all different, some disintegrate much faster than others. And by counting how many disintegrations there are per second, they call it becquerels, they use the word becquerels. When they say, for example, something is 7 million becquerels, You know what that means? It means that there are 7 million atoms exploding every second. That's 7 million becquerels. So the word becquerel means 1 disintegration per second. And by counting how many disintegrations per second they are and measuring it, they can then predict how long it will take for half of the atoms to be gone. And in that way, they can calculate what will be the half-life of that substance. Because nobody knows, and this is something they discovered very early, nobody knows how to stop radioactivity, nor speed it up, nor slow it down, no matter what you do. Temperature, pressure, chemistry, nothing changes the rate at which the radioactive disintegration occurs. And so the half-life remains constant no matter what you do to this stuff. It's a that's a very good question, and you will find that in some cases they're not quite sure what the half-life is because it's a little too confusing.
See,
Yes.
that's the most important point of all, in my opinion, the fact that there is no way to get rid of nuclear waste, such that the only adequate dispensation as opposed to disposal, which is basically impossible, is the one you describe. And that's what we all, those of us who don't want to put the hole or transport it to a hole, we have to have a better idea, or
Right.
best thus idea, which is to work on keeping it in place and creating better and better containers in place. And somehow the general public have to get that there is no way of disposing
Right.
of it, and that transporting it and burying it, it makes the situation infinitely worse. And so we have to focus on convincing the generators of the waste to figure out what to do with it on site.
Well, I certainly agree with you. However, I want to mention to you one thing, though, and that is that the generators of waste have another agenda. And the agenda they have is they have a business,
Yeah.
and they make a lot of money out of this business, and they want it to continue. And they have been told by reports that came out in the 1970s. There was a whole flurry of reports that came out in the 1970s. One of them was Canadian. It was the Ontario Royal Commission on Electric Power Planning. It said if they do not solve this problem of radioactive waste, then there should be no more nuclear reactors built. And that's why they want to find a place to bury it, because they know that the alternative is the end of their industry. And so they have a conflict of interest. The conflict of interest is how do we keep our industry going and our jobs going and our, all of that, unless we convince people that we do have a solution, even if we don't. And so that's the problem. Now, I certainly agree with you, but one thing I would add, and this is not, as you I'm sure appreciate, this is far from a simple problem. There are no simple solutions, and even when we talk about keeping it on site and looking after it, which I agree with, that's not really a long-term solution. Because why? Because things happen like wars, things happen like glaciers coming down, things happen, disasters happen. And so therefore it's not a permanent solution. We don't really know a permanent solution. Nevertheless, I think it's the most responsible way to look after the waste for, and we can certainly do it for centuries. There's no doubt about that. There's really, and even the nuclear industry does not disagree. They agree that you can look after this waste safely for many centuries. In fact, they're doing it already with other waste. They're keeping some radioactive waste on the surface. In Port Hope, for example, they've got nuclear waste that they were looking for a home up here in Northern Ontario for that waste from Port Hope, Ontario. But they were unable to find anybody who wanted to have it. So now they're looking after it on the surface at Port Hope, and they're saying they're looking after it for 500 years. So they're doing it already. And why? Because they couldn't get any northern community to accept that waste. Well, it could happen all over again. We could have a repeat performance. If people in the north say, no, we do not want it up here, then they'll once again have to look after it where it
Well,
is.
that's get more publicity. I mean, I'm talking about activism.
That's right.
Those of us who don't want it buried or transported for obvious reasons. I mean, the specifics of the danger are fascinating, but they're also basically irrelevant. The top and bottom line is that it shouldn't be buried or moved.
Well, the
And
important
so
thing is
the
that
people who do the right thing should be public, and we should hear more about that. And we should be able to be verbal and vocal about those people who are doing the right thing. So thank you for teaching us the specifics of the relatively right solution as distinct from the obvious thing.
I just want to mention, you said there's no way of destroying radioactive waste. There's some ways that you could think of that would in fact destroy radioactive waste. If there was a way, and we don't have such a way, but if there was a way to safely take the waste up into space to the center of the sun, that waste in the center of the sun would actually tear those atoms to bits, would tear them into protons and neutrons, and the waste would be destroyed. So there is a possibility of destroying this waste, but there's no way that we know of that can safely be done on Earth. And any way we have thought of so far, and they have thought about this, the idea is to try and somehow do something with the waste that will destroy it or change it into some. For example, if you could change very long-lived waste into very short-lived waste, then you could have an improvement of some sort. But they're far, far away from any real solution there. But I just wanted to mention to you that theoretically, there's no reason why, remember I said 84 years, that's not a very long time. If we wait a couple of 100 years, it's quite possible that something will be discovered that we don't know about, that will actually make it possible to neutralize this stuff and get rid of it. Either get rid of it by getting off the planet completely, safely, or get rid of it by destroying it or rendering it harmless. This is not beyond the possibility. So why bury it when we don't know it's going to be safe down there, when we know how to look after it on the surface for a long time, and there's a very good chance that we will invent a way of dealing with it. But meanwhile, let's not make any more.
And is there the possibility, I think you may have already explained this to me, is there not also the possibility of our learning over time to harness the remaining so-called waste, which wouldn't be dangerous if it weren't still viable?
You put your finger on something there. We had a speaker just the other day who thinks along those lines. His name is Dr. Peter Ottensmeyer from the University of Toronto. And I have looked very closely at this as well because I'm genuinely interested. In fact, when I went to university, I was very interested in nuclear science. I even thought of going into nuclear science myself. And one of the things that has bothered me about this whole field is that people are not told the truth. And in fact, they're not even given enough information to truly understand the problem. So it's all kind of like mysterious, and it's kind of like, and it makes people feel stupid or helpless because they say, why can't I understand this? And because if you don't feel that you understand it, then you don't feel you can even ask the right questions or make the right objections or say the right things. And I think the industry is, I'm an educator, I'm a teacher, and I think it's very, very wrong for the industry to keep people in the dark by not explaining it in simple terms. People can understand this if it's explained to them. You people have learned a few things tonight that you didn't know before. It's not too difficult to understand. It's just a question of having the will to explain it. And one of my main concerns is I fully agree that it's society's choice to what they want to do. If they want to take this risk, I'm just an individual. I may not like it, but that's society for you, right? And if a community wants this waste, well, I figure it's their decision. But on the other hand, I think that people have to be informed. And the United Nations Declaration on the Rights of Indigenous People really should be for all people, not just Indigenous people, because we're all ultimately Indigenous, I suppose. You think about it that way. But it says that you have to have free, prior, informed consent. Well, free means free of pressure. Well, we're getting nothing but pressure. All this money that's being thrown around, it's all pressure to try and get to yes. So it's not really free in that sense. Informed, it's not really informed, right? And what was the other one? Free prior, it's not really prior, because we should have known all this information before they even started. So I feel that this is what bothers me as a human being and as a scientific educator. I think that people need to be told the truth. The problem needs to be explained to them in simple terms. They can see what the options are, and they can make an informed choice. But I couldn't agree with you more. That more people should. And another thing that I don't like about the nuclear industry, there's some things I do like about it, but I don't think they're all bad people at all. I think they really believe that they're doing a good thing. But that doesn't mean that they are doing a good thing. You know, a lot of people think they're doing a good thing and they're not really. But another thing that really bothers me about the nuclear industry is they have a way of presenting things in such a way that you have no choice, that there's no alternative. And that's unfair. You always have a choice. You always have a choice. And telling people they have no choice is, I think, not only anti-democratic, it's anti-human.
Well, they are a wolf in sheep's clothing.
Yeah, well, they certainly have a conflict of interest, that's for sure.
But also they present, I mean, they've run a little something to town in a bus, and I called it the nuclear food truck, because they sort of hid it in the parking lot, and they didn't advertise it, and when you got there, it was quite fun, and there was lots of merch and so on like that. But it was not real.
No. Let's see if anybody else has any questions.
Oh, yeah, no, I just wanted to ask, just recently in the news, I think a couple days ago, Ontario is saying they are going to invest in nuclear energy or whatever. And then there's Krista Freeland also saying they're willing to be a part of that. So my question is, I mean, yes, we can have all of these forums out for people, but they still, in the news, still refuse to really explain the dangers of it, because they're saying it's a solution to electricity. But we have to look at ourselves and say, well, how much electricity do we really need? Like, there has to be other renewable, zero, damage to ourselves, the animals, the environment, the water, the air, everything. So, what's the best way to really fight this David and Goliath fight? It's so frustrating. It's so, and it actually makes you kind of sad, because if you've got the government on side with the big, nuclear industries, how can we fight against that?
Well, I feel equally frustrated. I feel equally powerless and so on. But I'll tell you, if you look at the history, when back in the days, 1977, I participated in the Royal Commission on Electric Power Planning hearings that took place in Toronto. And at that time, they were planning to build hundreds of reactors across Canada in many different provinces. And in fact, they were worried that they wouldn't be able to build them fast enough to keep up with the demand. Okay? Now, that report came out in 1978, September of 1978. It was called A Race Against Time, and it was about nuclear energy in Ontario. And it said that in their view, there should be no more nuclear reactors built unless they can solve this waste problem. And they also said, and this is almost a verbatim quote, they said, far from promising energy self-sufficiency for Ontario, nuclear power at best offers, I think they said controversy, or something, that all it was going to do was cause controversy and not really solve the problem. And they recommended that no more nuclear reactors be built at least until the year 2000. This was back in 1978. They thought the problem would be solved by then. They thought that the industry was, because the industry was telling them, oh, it's not really a problem, we can solve that easily. Oh yeah? Show us. And the point is they haven't done it. Now, but here's the thing. You know what? Since 1978 to the present time, there has not been a single nuclear reactor ordered or built in Canada. That's a long time. And I was told when I started getting into that at that time, they said, you're beating your head against a brick wall. They're going to build hundreds of these things. They never built a single one. They never built a single one. Now, I moved to Quebec in 1976 I grew up in Ontario. And then I went up to Vancouver for my education. And then I moved to Quebec. And when I came to Quebec, they were already planning to build 50 nuclear reactors along the St. Lawrence River. They were already choosing sites. They already had one reactor built and operating, the Gentil 1. They also were under construction with another reactor, Gentil 2, and they had already promised to build Gentil 3, all of them near the village of Trois-Rivières. But they were planning to build 50 more reactors along the St. Lawrence River. I and some friends of mine went to Quebec City and we presented our evidence about the dangers, the reactor safety accidents, the waste, and all that. And you know what? Not one of those 50 reactors ever got built. And in fact, the Gentil, and when the Quebec government declared a moratorium on nuclear reactors, they said, we don't think any more reactors should be built in this province. But they said, we exclude Gentil 2, which is under construction, and Gentil 3, which is already promised. Well, guess what? Gentil 3 was never built, and Gentil 2 has now been shut down permanently, and Quebec will not build any more reactors. So things that are said to be impossible turn out not to be impossible. They turn out, saying it's impossible is just another way of teaching people to be helpless. It's a way of getting people to feel powerless. And if you feel powerless, you are powerless. And so you really just have to take the power into your own hands and have confidence that even though you don't seem to have power, that power nevertheless, I didn't have any power to stop the nuclear reactors in Quebec. I really didn't. All I did was I just got a bunch of other people who happened to have more power than I did to see that it wasn't a good idea, and they went along with it. Our government right now is being hoodwinked by the nuclear industry. They have infiltrated into the government so much that when you go there, all of their nuclear advisors are from the nuclear industry. All of the people who advise them about nuclear issues. And so they themselves are being fooled and tricked, I believe. And I think it's really, this is the way I look at it, okay? This is my personal opinion. Don't take it as fact, it's just my look at things. I believe that what the industry sees is that they have been declining for the last 25 years. The nuclear contribution of nuclear electricity to the world's energy, to the world's electricity supply, 25 years ago it was 17% of the world's electricity. Today it's less than 10%, and it's still going down. And there's fewer reactors in Canada today than there were 10, 15 years ago. And there are fewer reactors in the United States than there were 15 years ago. And there are fewer reactors in Europe than there were 15 years ago. Why? Because even though they're building a few new reactors, they're shutting down the old ones faster than they're building the new ones. And so globally, the nuclear power industry is not doing well. Now, when climate change came along and people really started finally getting the message about, and by the way, it's not the people who have trouble getting the message, it's the leaders, the so-called leaders. The leadership comes from the grassroots. And when the grassroots finally got the message through to their dumb leaders that you got to do something about this, then the nuclear industry realized that there's going to be trillions of dollars made available to fight climate change. We got to grab as much of that money as we can. And what the nuclear industry is doing is they are working very hard to get government to give them big chunks of money to fight climate change. And what we've been pointing out to them, and Renee has done a wonderful job on this through her organization Northwatch and Nuclear Waste Watch, and through our organization, Canadian Coalition for Nuclear Responsibility, we've been pointing out that nuclear power is too expensive and too slow, despite all the other problems, to really make a difference. If we really want to reduce carbon emissions, the best thing to do is energy efficiency, renewables, solar and wind, which are 4 times cheaper than nuclear. As a matter of fact, the International Energy Agency, you can look this up on the website, the International Energy Society, because once that plant is finished, you just bury the whole thing. It all becomes radioactive waste and inaccessible for recycling. Whereas solar and wind are renewable and recyclable. Not to say there aren't problems, and I'm the first to admit that there are problems, and one of the problems is the mineral availability for all those batteries and all those other things. So I'm not saying that it's a magical solution, but it works. And it's obviously the best way to cut down carbon emissions quickly. And that's what we should be doing. So I think that our leaders are, unfortunately, and I don't think they're just misled, I think they're also acting maliciously. I think they're doing things for the wrong reasons.
We have another question at the Hi. I was gonna ask, is uranium a rare earth mineral?
No, it isn't.
No, it's not.
No. Actually, the definition of rare earth is kind of strange. If you look at the periodic table of elements, there are two, well, you know, the periodic table of elements has row after row after row, right, of all these elements. And there's two places where they have like bands of elements that don't fit into the table, and they pull them out and make them as separate bands. One of those bands is called the lanthanides, and those are the rare earths. And the other band are called the actinides, and the actinides include things like uranium and thorium and plutonium and so on. So the actinides and the lanthanides. And the rare earths are actually not all that rare, in fact. They're not all that rare, but they are very dangerous to mine. Mining rare earths is not a simple thing. I myself have fought against rare earth mines in Quebec, in Temiskaming, and also in Narsak in Greenland. I was sent there by the Physicians for Global Survival. They received a message from the Greenlandic people, who are Inuit people in Greenland, to, if some medical person could come and explain to them the health dangers of rare earth mining and uranium mining. And the Physicians for Global Survival chose me as a representative, and they sent me to Greenland to speak to these people and explain to them. That project has now been stopped, because it would have been disastrous for the village of Narsak and for the Inuit people there. But that doesn't solve the problem, of course, because I think that's a whole other topic that we should discuss for sure. But I think that those problems are, I think, more manageable on a human scale than the problems we're talking about here.
Have you ever been asked to speak in Ignace?
No. As a matter of fact, that's a very interesting thing, because Ignace is one of the only communities that I was not invited to speak at. I was invited to speak at Schreiber, and within 2 weeks after my speaking there, 2 months after my speaking there, they dropped off the list. I was asked to speak at Hornpain. I spoke there twice, and they were dropped off the list. I was allowed to speak at Manitouage. I was invited by the CLC, the Citizens Liaison Committee, and they were dropped off the list. People sort of, it's probably just coincidence, but people said, all you got to do is send Gordon there and they'll drop him off the list. But not that simple, of course. But no, I was never invited to speak at Ignace, and I always regretted that. I would have liked to have gone. I spoke at South Bruce, and I didn't stop them. They're still going ahead. But I spoke there. I didn't quit there until fairly recently. And by the way, when I spoke at South Bruce, I brought up for the first time in most of the people's knowledge the idea that they had to repackage this fuel before burying it. They didn't know that. There are lots of things they didn't know. And so when I go and tell them, and what I've discovered is that the reason our nuclear industry loses some of the battles I've been engaged in is not because I'm smarter or because I know more or anything like that. It's because people get mad when they find out they've been lied to. And when they find out that the people they were trusting have lied to them, that's when you really win the battle. So you don't have to call them liars. You just have to show people that they were not telling you the truth, and let them draw their own conclusions. And they quickly see that these people are not to be trusted because they're just not telling you the whole truth.
Any more questions back? Yeah.
From my perspective as an elder, your words, the way you talk, how fast you talk, the time you're starting, won't work in a First Nation community. You will need an interpreter. You will also need to start earlier.
Oh, okay.
And talk slower.
Yes.
And take your time, because for me sitting here, you lost me about a half hour ago.
Okay.
Because it's hard words.
You're
And I'm
right.
trying to, English is my second language. My first is Anishinaabe. I'm trying to, in my mind, translate these words as you're talking. That's why I'm a half hour back of you. We'll catch up.
I understand fully what you say, and I understand very well that it's so difficult to listen. I find it very difficult to listen, follow a conversation in French, even though I studied the language for 5 years in high school. I get fatigued very easily. And it's even worse when the subject matter is so foreign. The subject matter is so far apart from your daily life, from your daily experience. So thank you for that. I appreciate that, those comments. I would have liked to speak slower, but I always do have an inclination to speak a little too fast. But there's a trade-off there. You don't want to keep people too long, and yet at the same time, you don't want to talk so fast that you lose them. So I apologize for that aspect, and I appreciate you pointing it out. Thank you.
So there's a question, I think you were next.
Yep.
So, I also have a question for you. Can I ask you a question?
For me.
What is the native word in your language for radiation? What would you say?
What you want?
What does that mean literally if you translate it?
To translate it would be
Evil.
an evil entity.
Okay.
Evil entity.
I've asked this question of many indigenous peoples, like the Inuit, for example, in Baker Lake. When I was up there, I asked them what their word for radiation was, and they have a word, and I asked them, what does it mean? And they said it means poison air. And so when they were listening to the pro-nuclear people speaking, one of the things they said is that maybe a little radiation is good for you. And they all laughed because the way it comes across is maybe a little poison air is good for you. And but it's interesting to know how the native language uses their words to describe radiation, because of course it's something that is only new to all of us. You know, for the last, we didn't know what it was either until the year 1896. That's the year that radiation was first discovered and identified.
Go ahead.
Hello, my name is Nisha. I'm from the Ojibwe Nation of Saugeen, which is located near Sinette Lake, beside Ignace. In 2019, I found out about nuclear waste in a focus group in Ottawa. And since then, I've been advocating and I've been organizing, speaking, and networking with people from like all over who have been dealing with nuclear waste, from like the Algonquin and Chalk River, the Algonquins from the Ontario side, the Quebec side. And then I spoke with people of South Bruce, I spoke with people in Elliott Lake. You know, I spoke with many people who have been dealing with nuclear waste, including Christy Belcourt, who designed this T-shirt for us for the walk that we did against nuclear waste. With my cousin Darlene Ekan, who's been walking against nuclear waste. I believe it's going to be her 4th year this year. So I'm holding the water that we just did ceremony with, and I think it's really important that the conversations that we have. For myself, I talk about the water. I talk about how important the water is to the animals and all natural existence, and the forest and the people and the surrounding communities, and so on and so on. And a lot of people, they share that common ground with me, so we kind of have these really amazing conversations. So in Ottawa, we're starting a new radio show. It's called Red Road Media. So it's going to be a group of women who are going to be interviewing people from all over to talk about what's happening in their communities and what they're dealing with. Like for myself, I'm dealing with the ring of fire and nuclear waste and mining forestry. So we want to bring light to the conversations, not just in Northern Ontario, but also in Ottawa, because a lot of the decision making comes from Ottawa. So I have cards here, so I think we're going to be conducting interviews with who would like to speak with us, and we can amplify the voices and advocate against nuclear waste, because it's really hard doing it by ourselves, but to know that there's support and different organizations and people and volunteers and grassroots organizers, and we did Nuclear Free North and all these different people, I think it's really possible to do. And I just wanted to share that because I traveled here from Ottawa to come be here with you. I'm very honored and very, humbled to be in my own, territory, being a 60 scoop, I returned home. And I think it's really important for us to put our voices together so we can protect the secret. That's it.
And by the way, I don't believe it is too late. I think that NWMO has not got the permission to do it anywhere. And they're just trying to get a yes, and they're pulling out all the stops to do it. But people have shown in the past, as I mentioned with the Port Hope Place, people have shown in the past that they can say no. And when they all say no, they have to do something different because they don't have that option. So it's not, I don't believe it is too late. In answer to the saying that I should have started earlier, I'm just an ordinary person. I'm not on a crusade really. I'm just simply trying to help people to understand that because I have a scientific education and because I'm a teacher, I can help. That's what I'm doing. I'm trying to help people. And when I don't go anywhere I'm not invited. So I would never think of coming here and saying, listen to me. If I'm invited, I will be glad to come and speak.
We're getting close to 8:30. I've seen 2 more questions, so maybe go ahead with your question.
Yeah. Informed consent involves hearing both sides of the story. And so there are obviously people that have a very different viewpoint from you.
Right.
I think you'd have them for lunch. But it would give a lot more credibility if both sides of the story were being heard so that the one side could be properly rebutted. Little of my background, in a way, somewhat similar to yours, except I was a teacher of high school physics. And as part of that, a very brief introduction to nuclear physics and atomic energy and even atomic bombs was part of the curriculum. And I was always of the position that I should make students very wary of this. The whole issue of nuclear plant safety and the whole issue of disposal of nuclear waste with all the steps that are involved. And I was not aware of many of the points that you raised today. Anyway, thank you for your presentation. It was very interesting.
Well, as a matter of fact, years ago, I was contacted by a man named Pierre Burton. Does anybody know Pierre Burton? Well, Pierre Burton wanted me to debate nuclear power with a man from the United States who's quite famous called Dr. Edward Teller. He's known as the father of the H bomb. And he worked along with Oppenheimer on the Manhattan Project. And so we had an hour-long televised debate on Global TV, and it's on my website. I'll send a link to any of you who want to look at it, including yourself. I'm going to pass around this sheet of paper, and if anybody writes their email down on this list, I will send that to you, and I will send you other information. And I'll also, if you wish, I'll add you to my email list so that you can receive various mailings on this subject. I'll be happy to do that, so just add it to. As it turns out, I'm going to be debating the president of the Canadian Nuclear Association on Tuesday of this week coming up. And it's going to be broadcast. It's going to be live streamed. It's at the University of Ottawa, and it's sponsored by the International Association of, what's it called? The International Policy Institute. Institute for Policy Analysis, that's what it is. Anyway, it's so I'm going to be debating the president of the Canadian Nuclear Association and any of you can watch it, the debate, if you wish. I did debate people from the nuclear industry for many years, and finally, starting in 1970 when my organization really got active, and finally around 1978, Atomic Energy Canada Limited enacted a policy saying that nobody from Atomic Energy Canada Limited should appear with me on the stage at all, because they kept losing these debates. And in fact, I can't resist telling you a story because it's quite funny. After the Porter Commission, I by the way, was retained by the Porter Commission, that's the Royal Commission on Electric Power Planning. They issued that report in September of 1978. They actually gave me the permission to cross-examine nuclear experts on a daily basis for 3 months. And I was able to make a lot of inroads by questioning them under cross-examination. And a lot of that ended up in the report. And so the industry regarded me kind of like public enemy number one. And they said to people that the reason they keep losing debates is because the audience is biased. The people who come out to these debates are all anti-nuclear, and so they're all voting for Gordon Edwards instead of listening to us who really know the truth, and so on. So somebody heard this and they said, okay, let's organize a debate which is fair. We'll have the Supreme Court Justice Crever, K-R-E-V-E-R, we'll have him be the moderator of the debate, and we will send out randomly to Hamilton residents an invitation to come and listen to this debate without any prior knowledge. We'll pay them $100 to come and act as jurors to listen to the debate and judge whether or not who won the debate. And so so they got 50 of these jurors, and they had an audience of about 200 other people who were absolutely forbidden to clap or applaud or whistle or stamp their feet or do anything that would indicate any preference, because they didn't want the jurors to be contaminated, right? So, and then the juror went away and decided, and they came back and they voted overwhelmingly on our favor. And that's when AECL said, no more. We're not going to debate this guy anymore. So that put an end to that. So it's not I who has ever shirked debate. It's the nuclear industry that has shirked debate.
Just one question
Well,
here.
just a quick follow-up on the subject of debates. So glad to hear you've done all of that. Doesn't TV Ontario have an obligation to the citizens of Ontario to be running and rerunning those debates?
Well, it was a different television network. It was global TV. Even the National Film Board of Canada couldn't get access to it. And so I had my own personal copy, and I gave it to the National Film Board of Canada, which was probably unethical in a way because it wasn't my property. But you know what? My mother had gone to Pierre Burton and said, my son is having his birthday next month, and I would love to give him a copy of this debate. And that debate is on our website, so if you want to see it, you can see the debate I did with Edward Teller back in 1974.
I think TV Ontario has an obligation to present the two sides, as Dave suggests.
Well,
So
talk to them.
we can pressure them to do that.
So, Kat has a question.
Yeah, I just wanted to ask, so when you talk about all of these bundle of these big packages that racking up down Southern Ontario, how big is one package? I'm just trying to visually imagine the
Okay,
size.
well, a bundle is about this big. It weighs about 54 kilograms. It's heavy, very heavy, heavier than lead. It's about twice as heavy as lead. And it looks like just a very smooth, gleaming, metallic collection of rods that have been welded together into a kind of cylindrical package. That's a fuel bundle. Now, those fuel bundles are packaged into trays, and the trays have 96 bundles in them. And then those trays are put into those large containers that I showed you the picture of with the safeguard seal, and those have about 300 and something fuel bundles in them. And then you have tons and tons of those dry. By the way, they can't put them into the dry storage right away. They have to cool them with circulating water for 10 years. in order, because otherwise, if they put them in the dry storage right away, they would overheat and even melt. So they can't put them in there. They have to wait until the radioactivity dies down a bit so that it will no longer cause, and even when they put it in the dry storage, it then still has to be air cooled. So they couldn't put it underground, because when they put it underground, it would overheat the rocks. And in fact, the rocks, they even have, I have this on my website too, even the rocks underground, even if they wait for 70 years before putting the waste underground, the rocks underground will continue to heat up as a result of the radioactive waste, and the temperatures of the rock will not return to normal for about 50,000 years. And that 50,000 year period they call the thermal pulse. And the reason they call it a pulse is because it's like a blip on the radar screen, because the actual toxicity of the waste is more like 10 million years, and they also have a graph showing the toxicity over 10 million years. So 50,000 years is a drop in the bucket. That's a little blip that they call the thermal pulse.
And we don't know how that'll impact the subsurface.
Now, the difficulty is that they have to space the waste out. The reason they have to space it out is because if they put it too close together, they can exceed the boiling point of water. And they don't want to do that because that creates steam, and that would allow waste to possibly escape by the steam pressure. So they have to space the waste out. And the volume of the waste is not important. What's important is the heat generation. So the size of the repository doesn't depend upon the volume of the waste at all. It depends upon the heat generation. And they space it out so that at the midpoint between two placements, the temperature will not exceed 100 degrees. Usually they aim for something like 92 degrees so that the water doesn't boil. Now that's all very well and good, but what if there's chemical reactions that add to the heat load? For example, if they put fuel down there that had sodium metal in it, which they're now planning to do, or which they could be planning to do, then you can have chemical reactions that add to the heat and exceed the boiling point. And then you do get steam buildup, and then the trouble with that is your safety piece goes to hell. Now what's even worse is that now they're planning to put waste down there which is enriched uranium. We don't use enriched uranium in Canada, we use natural uranium, which cannot undergo a spontaneous nuclear chain reaction all by itself, even in the presence of water. On the other hand, the Americans use enriched uranium, which, if in the presence of water, it can spontaneously develop a chain reaction, which generates a lot of heat. And so there you could totally jeopardize the repository. Now they want, with these small modular reactors, to put enriched uranium fuel down there. Now they space that out too, so that fuel bundles will not allow a chain reaction to occur. But over the centuries, corrosion sets in. And when corrosion sets in, this stuff eventually pulverizes, and you can have it flowing together in configurations that were never planned. And so you can have pooling of the waste in areas where you could get a spontaneous nuclear chain reaction. That would absolutely blow the lid off the repository. So they're doing things now which are far more dangerous. They're planning to do things now. They're not actually doing them yet. But they're planning to do things now which were never in the original plan for the NWMO using CANDU fuel only. And they're not saying a word about it. And they're breaking their promise that they were only going to put the CANDU fuel down there. So these people are really behaving very dishonorably. And no matter how they tell you that they know the science and they know what's right and they know the good thing and they're keeping their promises, they are not. They are trashing their promises left and right. Already. And they haven't even built the thing yet.
So, getting late, I think we can take one last question over here.
And actually, it's not a question. I wanted to thank everyone, but I wanted to also say that, so I'm Bernane and I'm with Northwatch. We're part of We the Nuclear Free North, along with Kathleen and Nisha and Alo. We're very blessed to have him as our advisor. And one of the conversations, this follows from something Nora said, one of the conversations we've been having is how do we get the news magazine shows to engage in this discussion? So TVO, W5. So I think, Nora, it's a great idea, but we have pitched the idea to them, but really the listeners and other people need to say, we're not hearing enough. This is important in our region, and we're not hearing enough. And, you know, we all learn different ways, and there's so much, as you can tell by it being almost 9 o'clock, there's so much to say that we really need to have different news outlets providing different coverage. APTN does great work, but most of the mainstream media do not. So that's my one item. And the other one I wanted to say to everyone, there's lots of material here, so please take it away. And I'm going to ask Gordon to share the emails he's collected, but there's also a petition here that you can take copies away of, and it's for something called the proximity principle. What Gordon's been talking about rolling stewardship, we call it robust storage, improving the way the waste is managed at the site, rather than going down this, you know, this rather, you know, incredible path of moving it and burying it and abandoning it. So I just wanted to say thank you to everyone, but I also wanted to pitch to share your email, take some petitions, take some materials, and speak up and get the media to speak up, to let those voices be heard. You know, Gordon and others, we're always ready for debate. So thank you. Thank you.
I have 6 emails here. If anybody wants to add their name to the list, they can come up here and do that, or they can write to me. My email is very simple. It's only 4 letters. CCNR stands for Canadian Coalition for Nuclear Responsibility. CCNR@web.ca. If you just drop me a line, I'll put you on my mailing list and send you the same resources I'm going to send to these people, or alternatively, you can add your name to